Hi, welcome all to the online classes. I'm Mukesh Bhardwaj, going to present a topic, polarization in BTech first semester. The subject is physics. So polarization, what do you mean by the polarization and how the polarization is helpful, or what are the sense of means of polarizing a light, or like polarized and unpolarized light? What is the difference between the polarized and unpolarized light? Light is polarized when its electric field oscillate in a single plane rather than in direction perpendicular to the direction of propagation. So polarization is a property of wave that can oscillate with more than one orientation. So basically, polarization is nothing. It is a property of wave that can oscillate with more than one orientation. Electromagnetic waves such as light exhibit polarization, as do some other types of waves such as gravitational wave. Sound waves in gas or liquid do not exhibit polarization, since the oscillation is always in the direction the wave travel. So we can say that polarization is a property of wave, or electromagnetic waves, especially having the property of polarization. They contains electric field and magnetic field in perpendicular to each other. So we can say the electromagnetic waves are having the polarization property. Light is an electromagnetic wave. So light basically is an electromagnetic wave which is having magnetic field, as you are seeing that it is in the blue color, an electric field which is in the pink color, and both the fields are perpendicular to the direction, perpendicular to each other, and propagate in the direction of propagation. And the wavelength is just difference between the trough to trough and crust to crust difference is called the wavelength of the light. So light is an electromagnetic wave. Electromagnetic wave, light is an electromagnetic wave. It consists of vibrations of electric field and magnetic field. The electric field, uh, the electric field and magnetic field are perpendicular to each other and in phase. Electromagnetic wave is transverse wave. The speed of electromagnetic wave is 3 into 10 to the power 8 meter per second. So in 1864, James Clerk Maxwell proved theoretically that all the properties of light waves are present in the electromagnetic waves, and by the observing the similarity of these waves, Maxwell proposed a new theory for the nature of light. According to the Maxwell, the light waves are electromagnetic waves. In an electromagnetic wave, electric and magnetic field vectors are perpendicular to each other and very simple harmonically in the same phase in the plane perpendicular to the direction of propagation of wave. Thus, the electric field vector and the magnetic field vector and the direction propagation of wave all are the three perpendicular to each other. That is, light waves are transverse in nature. Emission of light from atoms are due to transition of electrons from excited states to lower states. Light ray is made up of a very large number of electromagnetic waves in which electric field vectors of different waves vibrate symmetrically in all possible outcomes or directions perpendicular to the direction of propagation of light. Such a light ray is called unpolarized light. In general, in ordinary light, electric field vibrates symmetrically in all possible directions perpendicular to the direction of propagation of light. If the direction of propagation is taken normal to the paper, then unpolarized light can be represented according to the some wavefront, uh, or you can say in a circular motion. In the vibration of electric vector and are confined in a definite direction or directions by any means, then this state of light is called polarized light. and the phenomena is called polarization of light. So polarization of light basically means when we are going to confine in a definite direction which vibration of electric vector, the vibration of electric vector are confined in a definite direction or direction by any means, then this state of light is called polarized light and phenomenon is called polarization of light. Thus it is clear that in polarization of light, the distribution of vibrations of electric field vectors become asymmetrically or asymmetrical about the direction of propagation of the wave. If the electric field vectors are and the direction of propagation are confined in definite plane, then the light ray is called plane polarized. Then the light is known as the plane polarized. If the head of the confined electric field vectors rotates with constant amplitude in plane perpendicular direction of propagation, that is the head of electric field vector rotates in circular path, then light is called circular polarized. And if the head of the confined electric field vectors rotates in elliptical path, then the light is called elliptically polarized. There are some experiments which shows the polarization. And the mechanical method or the mechanical way of understanding the polarization, take two slits are placed parallel to each other. A string is passed horizontally through S1 and S2. Transfer waves are set up along the string by holding one end of the string in the hand and moving it up and down in all directions perpendicular to the string. When both slits S1 and S2, and only those waves whose plane of vibration are parallel to the slits will pass through both the slits. Now keeping slit S1 fixed and S2 is rotated gradually, the amplitude of the vibration emerging from the slit 2 decreases when slit S2 is turned so that it is perpendicular to the earlier position. So transfer wave passes through the slit 1, but it does not passes through the slit 2 and stop there. The reason is that if the waves between S1 and S2 assumed to be the plane polarized, whose vibrations are parallel or is parallel to the slit S1, then this vibration will not pass through the slit 2, being perpendicular to it. If the slit S2 is turned further, then the amplitude of the vibration emerging out of the slit S2 increases. When slit S2 becomes parallel to slit S1, then amplitude of the wave emerging out of the slit 2 becomes maximum. If longitudinal vibrations are set along now the optical method, this is the mechanical method or the experiment for justifying the polarization. Optical method, the experimental arrangement is shown such like that in which A and B are two taurinline crystals whose axes are parallel and these are kept in front of each other. When the light is passed through them, the emergent light is seen as dark green. Now if crystal B is rotated with respect to crystal A, then the intensity of light decreases gradually, and when the axis of the crystal B becomes perpendicular to the axis of crystal A, then the intensity of light becomes 0. Now the crystal B is rotated further, the intensity of emergent light increases again and become maximum when they are parallel. In one complete rotation of the crystal B, the intensity of emergent light becomes maximum 2 times and becomes minimum 2 times. This crystal work as slits used in mechanical experiments. This experiment proves that light waves are transverse in nature. If the light wave were longitudinal, then there should be not any change in the intensity of the emergent light. So the plane of vibration and plane of polarizations is when the vibration of all the electric field vectors in a light ray are confined in a definite plane. Then such type of polarized light is called plane polarized light. The plane in the plane polarized light in which electric field vectors in the direction of propagation of light both exist is called plane of vibration. The plane perpendicular to the plane of vibration in which components of electric field vectors are zero but contains the direction of propagation is called plane of polarization. Thus, plane of vibration and plane of polarizations are perpendicular to each other. When the vibrations of plane polarized light are parallel to the plane of paper, they are represented by arrows perpendicular to direction of propagation. When the vibrations of the plane or polarized light are perpendicular to plane of paper, they are represented by dots. Both representations will be shown in the next slides to you. So polarized light vibrations lie on one single plane only, and unpolarized light superposition of many beams in the same direction of propagation, but each with random polarization. So figure first is showing the polarized and figure second is showing the unpolarized. Methods of polarizing light. It is possible to transform unpolarized light into polarized light. So the four methods discussed on this page are polarization by transmission, polarization by reflection, polarization by refraction, polarization by scattering. So it is possible to transform unpolarized light into polarized light. Polarized light waves are light waves in which the vibration occur in single plane. The process of transforming unpolarized light into polarized light is known as polarization. So this process is basically known as polarization. That means when you are transforming unpolarized light into polarized light, then this is known as polarization. There are a variety of methods of polarizing light. The four methods discussed on this page are polarization by transmission, and these four methods are shown in the slide. So as you see the figure, incident beam unpolarized, polarizer 1 vertical, polarizer 2 horizontal. Vertically polarized light is shown passing from the polarizer 1. Polarization by transmission and polarization by reflection. So polarization by reflection, when unpolarized light is reflected from the surface of transparent medium such as water, glass, etc., then it becomes partially polarized. Brewster discovered that extent of polarization in reflected light depends upon the incident angle. So in figure second, the polarization by reflection, you observe that the polarization by reflection means when unpolarized light is reflected from the surface of a transparent medium such as water, glass, etc., then it becomes partially polarized. Brewster discovered that the extent of polarization is reflected light depends upon the incident angle. When the ordinary light, unpolarized light, is incident on a transparent medium at particular incident angle, then reflected light is completely plane polarized. The angle of incidence is called the angle of polarization, or IP, small ip. This angle depends only upon the medium on which the surface reflection and refraction takes place. The relation between the refractive index and angle of polarization is given by mu equals to 10 ip. That is, the tangent of the angle of polarization is equal to the refractive index of the medium for the light used. This is called Brewster law. For glass, mu is equals to 1.5, that is refractive index for the glass is 1.5, and for the hence uh, the angle of polarization IP is come out to be 57 degree. Experimentally, Brewster proved that when a light ray is incident on transparent medium at the polarizing angle IP, reflected light becomes plane polarized, and refracted light rays are perpendicular to each other. Now, polarization by refraction. When unpolarized light is incident on parallel glass plate at polarizing angle, the reflected light, and before discussing the polarization by reflection or refraction, I would like to discuss the polarization by uh, transmission. So as you see the slide, the picket fence analogy, when the pickets of both fences are aligned in the vertical direction, the vertical vibration can make it through both the fences. When the pickets of the second are horizontal, vertical vibrations which makes it through the first fence will be blocked. So this is the basic fundamental, or you can understand the polarization by transmission by a simple analogy which we had already discussed. Now we had discussed the polarization by reflection, and now polarization by refraction. So polarization by refraction, when unpolarized light incident on parallel glass plate at a uh, just wait a minute. Parallel glass plate at the polarizing angle, the reflected light from the upper surface of the glass plate is completely polarized light, uh, as shown in the figure, in which the plane of vibration of polarized light is perpendicular to the plane of the incidence, but the refracted ray is partially polarized. Refracted ray is partially polarized light. If the upper and the lower surface of the glass plate are parallel to each other, then the refracted ray will incident on the lower surface at the angle RP with the normal, where RP is the angle of refraction at the upper surface. Now, so this equation is called Brewster's law. 10 RP equals to G mu A for the unpolarized light in the medium. Thus, it is clear that when unpolarized light is incident uh, on the upper surface of the glass plate at the polarizing angle, then the refracted ray will also incident on the lower surface at the polarizing angle. Thus, the rays reflected from the upper and the lower surfaces of the medium will completely polarize, but the emergent light will be partially polarized. If a number of such plates are placed one above the other, and unpolarized light is allowed to fall on the first plate at the polarizing angle, then the reflected part becomes completely polarized, and the refracted part of the unpolarized light passes through the plates. The extent of polarization in the refracted beam increases with the increase in number of plates. If the number of plate is quite large, then the emergent light becomes almost plane polarized. However, the intensity of emergent light becomes very small. The arrangement of the plate is called the pile of the plates. Now, Now, polarization by scattering, when the light strikes the atoms of the material, it will often set the electrons of the atoms into vibration. The vibrating electrons then produce their own electromagnetic wave that is radiated outward in all directions. These vibrating electrons produce another electromagnetic wave. This scatter light is partially polarized. Polarizing material. A polarizing material will only allow the passage of that component of the electric field parallel to the polarization direction of the material. I equals to I naught cos square q. So this is the polarizing material. As you see that vertically polarized light, polarizer, direction of polarizer, I naught cos square theta, propagation, refraction. Polarization in everyday situation. This photograph should be compared with the one above. In this photo, the reflected glare that was seen on the water surface has been removed by the use of Polaroid filter. It is much easier to see the sidewalk below the water surface. In this photograph should be compared with one above. The reflected glare seen on the glass panels of the lab cabinet has been removed by the use of Polaroid filter. It is much easier to see what is present inside the lab cabinets. This is set of two photos provide another example of how a Polaroid filter can block the annoying glare that is caused when light becomes polarized upon reflection. Action of polarized sunglasses. Light reflected from uh, basically light reflected from surface like flat road or smooth water is generally horizontal polarized. These horizontally polarized light is blocked by the vertically oriented polarizers in the lenses. Vertically polarized light from the objects. Unwanted glares are usually horizontally polarized light. Stress analysis. Polarized light is often used in the stress analysis of molded plastics. Stress analysis. Polarized light is often used in stress analysis of a molded plastic. Polarized light passing through the molded plastic will reveal stress marks and stress pattern that would not otherwise be apparent to the naked eye. The plane of polarization of polarized light is rotated by these molded plastics at any location. Where the plastic is stressed, the amount of rotation depends upon the wavelength of light. White light consists of various wavelengths, each associated with a distinct color. Using a Polaroid filter and rotating, it will reveal stress patterns in various colors at various angles of rotation. So there is one more method of producing plain polarized light, that is double refraction or double refraction. When a light ray is incident upon certain crystals such as calcite, Iceland spar, the ray splits into two refracted rays due to the refraction. This phenomena is called double refraction and the crystal is called double refracting crystal. Another method of producing the plain polarized light is dichromes and polarides. Dichromes or we can say dichroism. When polarized unpolarized light incident on a tourmaline crystal, it split into two plane polarized rays. Out of these two reflected rays, one is selectively absorbed by the tourmaline crystal, and the other rays emerges out of the crystal without absorption. Without absorption, this action of the crystal is called dichroism. In this way, tourmaline crystal produce plane polarized light by transmission. Polaroids is a low-cost and commercial optical device for producing plane polarized light. It works on the principle of uh, dichroism. In order to prepare a Polaroid film, ultra microscopic crystal of herpathite, iodosulfate of quinine are spread on a thin film of nitrocellulose in such a way that the optic axis of all crystals are parallel. These crystals are highly dichroic, which absorb one of the doubly reflected rays completely. Now, this film is placed in between thin glass plates. In this way, a polarized film is formed. Working when unpolarized light rays pass through the Polaroid, it splits into two plane polarized beams. In one ray, the electric field vector is parallel to the axis of herpethite crystal and it is transmitted without any absorption, whereas the other ray, in which the electric field vector is perpendicular to the axis of herpethite crystal, gets totally absorbed. By the medium, thus the light ray emerging from the Polaroid is completely polarized. Oh, what are the uses of Polaroids? There are various uses of Polaroids. Being a cheaper device in comparison to nickel prism, it is used in producing plane polarized light as well in analyzing the plane polarized light. Uh, Polaroids are used to avoid the glare of light produced by reflection from bright surfaces. The light reflected from wet roads is partially polarized. This light reaching the eyes produces glare. If the windscreen of the car is made up of Polaroid, it will not allow such light to reach the driver. Polaroids are also used in fast trains and aeroplanes to control the light entering into them. Polaroids are used in the headlights of the trucks, cars, etc. to cut off the dazzling light of other car approaching from the opposite direction. Polaroids are used in studying optical properties of metals. Polaroids are used in studying the structure of optically active substances. Next. Polarization in 3D movies. Polarization is often implemented in the production and viewing of 3D films. When watching a 3D movie, there are actually two images being projected onto the screen at once. The two images were filmed with two separate cameras from two slightly offset locations. These two images are projected onto the screen through Polaroid filters. The molecules of one of the filter is aligned vertically, the other is aligned horizontally. The audience is given 3D glasses that have one lens aligned horizontally and the other aligned vertically. Thus, one eye sees one image and the other eye sees the other image. The brain receives both the signals and perceives depth on a flat screen. Seven segment display, the liquid crystal display LCD. You see the arrangement. Polarizer 1, polarizer 2, liquid crystal sandwich, negative electrodes, and finally the display is there. Aerial. In vertical transmitting aerial, vertical electron oscillate results in the vertical polarized radio wave. Maximum electron oscillation in the receiving aerial is achieved when the aerial is aligned to the parallel to the wave's electric field. While the sky is blue, the tiny particles in the atmosphere, dust, clumps of air, molecules, microscopic water droplets, are better at scattering shorter wavelength blue light uh, than longer wavelength red light. As the sunlight passes through the atmosphere, the scattered blue light gives the atmosphere an overall blue color. The sunset is red because at sunrise and sunset, sunlight enters our atmosphere at a shallow angle and travels a long distance before reaching our eyes. During this long passage, most of the blue light is scattered away, and virtually all that we see coming to us from the sun is its red and orange wavelength. Polarized light will not be transmitted through a polarized film whose axis is perpendicular to the polarization direction. When light passes through a polarizer, only the component parallel to the polarization axis is transmitted. If the coming light is plane polarized, the outgoing So, when light passes through a polarizer, only the component parallel to the polarization axis is transmitted. Uh, if the coming light is plane polarized, then the outgoing. So, as you see in the diagram, which is showing very clearly. Now, next. This means that if initially unpolarized light passes through crossed polarizers, no light will get through the second one. The polarization is also partially polarized after reflecting from a non-metallic surface at a specific angle called the polarizing angle or Brewster's angle. The polarization is 100%. Next, liquid crystal displays. We had seen this example of also the liquid crystals are unpolarized in the absence of the external voltage and will easily transmit light. When an external voltage is applied, the crystals become polarized and no longer. Liquid crystals can be found in many familiar applications such as calculators and digital watches. For color, LCD displays are more complicated. Each pixel has three subpixels to provide the different colors. A source of light is behind the display. Unlike the calculation, unlike the calculators and watches, which use ambient light, the pixels must be able to make finer adjustment than just on and off to provide a clear image. Scattering of light by the atmosphere. Skylight is partially polarized due to scattering from molecules in the air. The amount of polarization depends on the angle that your line of sight makes with the sun. Now the summary. Polarization, the wave theory of light is strengthened by the interference and diffraction of light. Huygens principle, every point on a wavefront is the source of spherical wavelets. Wavelength of light in a medium with index of refraction is given by the Young double slit experiment demonstrated interference. In the double slit experiment, the constructive interference occurs when this condition is to be fulfilled and the destructive interference when this condition is to be fulfilled. Two sources of light are coherent if they have the same frequency and maintain the same phase relationship. Visible spectrum of light ranges from 400 nanometer to 700 nanometer approximately. Index of refraction varies with wavelength, leading to dispersion. Diffraction grating has many small slits or lines, and the same condition for constructive interference. Wavelengths can be measured precisely with the spectroscopes. Light bends around obstacles and opening its path, yielding diffraction pattern. Light passing through a narrow slit will produce a central bright maximum of the width sin theta, which is given by the relation lambda by d. Interference can occur between reflections from the front and back surfaces of thin film. Light whose electric fields are all in the same plane is called plane polarized. The intensity of plane polarized light is reduced after it passes through another polarizer. Light can be polarized by reflection. It is completely polarized when the reflection angle is given as tan theta p equals to n. Now, as a polarization of light in polarized light, if the vibrations of electric vectors in any light waves are confined in a particular direction, by means by any means, then this state of light is called polarized light, and the phenomena is called polarization of light. Uh, when the electric field vector rotates with constant amplitude in plane perpendicular to the direction of propagation, that is, the head of the electric field vector rotates in circular path, then the polarized light is called circularly polarized light. We had discussed the various methods of producing plane polarized light. The following methods which we had discussed are by reflection, by refraction, by double reflection or diffraction, by dichroism, and by scattering. And Brewster law, and the Brewster law is the tangent of angle of polarization is equal to the refractive index of that medium of the light used. Nicol prism is an optical device by which plane polarized light can be produced and analyzed. Nicol prism work on the principle of double refraction. Polaroid, basically Polaroids is a low-cost commercial optical device for producing plane polarized light, which works on the principle of dichroism. So this is all about the polarization. Now the quiz time or questionnaires. When a pebble is dropped in a pond of still water, what happens? Particle moves, wave moves, the pebble moves, or water moves. The option B is right, the wave moves. The mechanical waves are called elastic waves. The statement is true or false. The mechanical waves are not elastic waves. The statement is false. What are the essential properties of medium must possess for the propagation of mechanical waves? A. Stable pressure. B. Maximum friction. C. Constant temperature. D. Minimum friction. So option D is right answer, minimum friction. Sound waves or sound travels through a gas under which of the following condition? A. Isothermal condition. B. Non-isothermal condition. C. Adiabatic condition. D. Transverse condition. So option C is the right answer. What kind of wave is formed in organ pipes? A. Transverse stationary waves. B. Electromagnetic waves. C. Mechanical waves. D. Longitudinal stationary waves. So option C is the right answer, that is mechanical waves. A wave transmit momentum. Cannot or can't it transfer angular momentum? Yes or no? Yes, it cannot. So the B is the right answer, that no, it cannot transfer angular momentum. What is the most fundamental property of wave? A. Temperature. B. Pressure. C. Frequency. D. Wavelength. The most fundamental property of wave is the frequency. Which among the following is not a suitable phenomena to establish that light is wave motion? Interference. B option diffraction. C reflection. D polarization. So option C is the right answer. The optical path of monochromatic light is same if it travels 2 centimeter thickness of glass or 2.25 centimeter thickness of water. If the refractive index of water is 1.33, what is the refractive index of glass? So apply the formula, get the solution. The refractive index come out of to be 1.5. Identify the condition which is not necessary for two light waves to be coherent. A. The two waves must be continuous. The two waves should be of the same frequency or wavelength. They should have a constant or zero phase difference. D option, the two light source should be narrow. So option D is right answer. Now, some questions which are theoretical need to be answered. What is polarization? Explain the polarization with the help of electric vector. Why is it property of transfer waves? Second, how will you differentiate between the following quantities? Plane polarized and circularly polarized, that is differentiate. Just create the difference between the plane polarized light and the circularly polarized. Left-handed polarized and right-handed polarized. Circularly polarized and elliptically polarized. Unpolarized and circularly polarized. So need to give the answer on these some theoretical questions. Next question is the describe and construction and working of Nicol prism. How can you use it as a polarizer and as an analyzer? So just describe the construction and working principle. Next, there are so many questions need to discuss. So that's all. That's all about the topic. Thank you. Thanks a lot.